So I'm going to talk a bit about getting KDE Plasma on Ubuntu Core. The reason why I'm doing this is that we've been working on that thanks to Canonical, who is basically funding that work. And I thought that could come in useful for people at large to have an idea about where the difficulties might lie if you want to do the same thing, right? I'm doing it for one desktop. There are more desktops around, and you might want to do something similar, and then it's a good idea to know what you're working into. I've been told that clicker to say, if you double-click, that will go, but that doesn't go at all. There you go. Just have to not be gentle with it. But before that, the vanity slide, basically. So I've been working around the KDE community for the past 20 years or so. Actually, as a matter of fact, it's not on the slide, but I actually remember in 2004 talking with a couple of free software contributors who were just joining a company called No Name Yet, which would become Canonical later on. And it's actually not my first Ubuntu Summit, because the first one I attended was in 2006 in Paris. And that was a very different kind of event back then. But that's interesting to be back. After this short trip down the memory lane, nowadays I'm working for Enyoka Haute Couture, which is a service company. So we are doing development for customers. We're also doing some consulting, training, coaching, and so on. As part of that company, I'm basically a lead developer, and I'm also a trainer and a coach. And I live in Toulouse in France. Now, let's get really in the topic. So there's Ubuntu Core, right? So Ubuntu Core, the official motto, kind of, is it's a minimal, secure, and strictly confined operating system. Initially, I mean, in the communication, you could tell that it was designed for embedded systems. That's basically the immutable version of Ubuntu, secured by design, containerized. Okay, you probably know quite some of that. All the components are in snaps, even the kernel and the snap daemon, snapd itself. You get the over-the-air updates with automated rollback if needed. That's the core promise for Ubuntu Core. Then last year has been announced Ubuntu Core Desktop, which is, I chose the motto there, but you could say it's a fully containerized desktop where each component is immutable and isolated. It's a full desktop session on top of Ubuntu Core. The idea is to get the same benefits, but for user-facing graphical interfaces. And so there, the promise is to have some security, because that's harder for malicious software to change the system or spread themselves among components. Stability, because the updates cannot leave the system in an unstable state because of the rollback system. Reproducibility, because it's easier to audit and verify such a system. And manageability, because if you have the same set of snaps, you basically have no inconsistencies from system to system, and you can predict what you would have. That said, it comes from some extra challenges compared to purely embedded systems, in the way that it's harder to draw the boundaries between the desktop components, which tends to be bigger, and there's more of them, and they like to chat to each other. Now, one part you might know a bit less about, that's KDE Neon. KDE Neon, that's the latest and greatest of KDE community software. This one is built on top of the latest Ubuntu LTS release, and it's a showcase of KDE exactly as the KDE developers intended. So there's no patches, there's no changes to the default settings when you're using packages coming from KDE Neon. And the idea is to get a stable Ubuntu base, but rolling KDE software. And you get a very up-to-date KDE Plasma experience thanks to that. Which leads us to today with KDE Neon Core. KDE Neon Core, that's all the KDE Neon benefits, so you get something which is up to date, but on top of Ubuntu Core instead of Ubuntu LTS. We designed it to follow a similar architecture to Ubuntu Core Desktop itself, except that it provides a Plasma-based user experience. The idea, again, is to get the greatest and latest of KDE software. And for that, that means that as part of the project, we have to provide building blocks to help snapping packages, KDE applications, to be able to use them on Ubuntu Core. Now, to understand some of the troubles you might get if you try such an endeavor, I'm going back a bit on the basics of how the snap confinement works. What we see very often is how to make a snap, right? So you write a build recipe, that's your snapcraft.yaml, and then you use snapcraft with that, build your package. In that recipe, you get many different things. You got some metadata, the targeted base system, the apps which are actually provided in the package. That can be one, but that can be more. The interfaces needed by the package or each of the apps, and you have to say if you want it as a slot or as a plug, if you're a provider or a consumer of that interface. And the packages which are needed to build your snap, and then the actual steps to build each of the parts which end up in your snap. An extract of a recipe, so that's coming from an example on the KDE side with the ARC application, which allows basically to look into your compressed archives. And we see some of that. So we are saying the name of the app, the type of confinement we want, the base, which in that case is core 22. We also describe where the information about the app is coming from. So here we're using the adopt.info trick, which means we're reusing the data which is already in the desktop file of that application. And some things you might notice is that we have plugs which are declared on the right-hand side for you, on the right-hand side of that recipe, and the KDE Neon 6 extension. We also have slots because KDE applications like to be on the bus, right, on the session bus. So we have to declare those to be able to run and to register there. Now that bears the question of, I just briefly showed that KDE Neon extension in the recipe, and then the recipe was kind of short. And that's thanks to this extension, which behind the scene positioned plenty of things which are useful for KDE applications. So the path is positioned, the XDG underscore whatever variables are positioned, and so on, so for the environment. We also hardwire through that extension the build time and runtime dependencies on KDE frameworks and Qt, because like 95% of our applications do that. And also we enforce some common plugs because that's desktop application, so we need access to desktop, and we need access to OpenGL and Wayland and the audio playback. Most of our applications need that, so it's hardwired in the extension. Now, once you have the snap and you kickstart your application, how does it work? That's basically a three-step process. The first thing which runs before your application is actually snap confine, which will set up the execution environment. In that environment, the home will be forced. There will be a bunch of snap-specific environment variables which are forced, like the snap variable, and I will get back to that particular one. You will see it has funny consequences for us. You get a private mount namespace so that you see whatever you need to see from the system. You get a private TMP directory. You get seccomp filters so that you cannot call any system calls unchecked, and an AppArmor profile. Then snap confine hands over the control to snap exec, which is started in this new execution environment. Snap exec will read the meta YAML file, which is provided with the snap package, and in there we'll find the actual command which needs to be run. Once it found it, it launches that actual command, and then that command is under the right environment and the right confinement constraints. If you declared your application as a daemon, then you get a systemd service generated by snapd. Okay, I'm coming back to this one because that will be important as well. And those ones, those services, they don't run the actual command directly. They go through snap run for that. Now, one of the questions is where are the seccomp filters and AppArmor profiles coming from? Basically, that's snapd, right? Snapd needs to create them when packages are installed or delete them when they are removed. And then depending on how you connect your slots and your plugs, snapd will update the profile of the application. The corollary of that is that inside of snapd, that means there's some code mapping the interface state to seccomp and ARPARMOR templates, right? So that's your way into extending what snapd does. All right, now for the KDE Neon architecture. So we have some important parts in there. Everything which is in orange on that diagram, that's basically what was already provided before we started, so that the different services that you can find for SnapCore in a system. The blue ones are the ones we've been working on. So one important one we've been working on is the Plasma Core 22 Desktop. That's the base snap which provides all the binaries which will be used to run an actual KDE Plasma session. Then on top of that, we have the Plasma Desktop session, which is a regular application snap. This one is really tiny. It's just a bunch of scripts to actually kickstart the process of the session, but the binaries are coming from the base snap. And then higher up, we have a few applications, and we have the KDE framework runtime, so that the KF6 snap that you see up there. There's a big difference between the way we deal with the session, at least the binary content of the session right now, and the applications. We chose different strategies for now, is that the Plasma Core 22 Desktop is populated with the KDE Neon Debian packages. And as for the applications, we're actually building them from source, from the code. We have a login manager, which is not GDM in that case, because we wanted to play with the idea of having like something completely different and what people would expect from a KDE session. So we're using SDDM, and this one is provided as well by the base snap. On first boot, the SDDM config is overloaded, and it only starts the Ubuntu Core Desktop init unconfined. And then the SDDM config is reset to default. So that you get your first user to be able to start the session. Fun fact, SDDM doesn't have that feature, right? So we had to kind of create it from scratch. GDM does that by default, right? You have a mechanism for that in GDM. Now that you got your first user, then you need to actually boot your session, right? You actually to start that session. And then on KDE Plasma nowadays, it's completely driven by systemd. So we got services which are declared for systemd. We have a graph of dependencies between those. We have the services. We have a few targets, right? And then we want to kickstart that. So on that graph, it's very simplified. I'm lying a bit because that made the graph prettier, basically. You can ignore the gray parts. They won't play much of a role in our story. The other ones will matter more in what I will explain next. The red ones are the interesting ones for us right now. It's because that's the only ones which talk back to systemd. Okay, so the Queen Wayland will talk to systemd, KSM server will talk to systemd as well, and Start Plasma, which is not strictly a systemd service, but that's actually the one talking to systemd to say, I want that target, make it happen. Talks also to systemd just for that, right? It needs to be able to say, okay, here is my target, now do your magic. That's the only thing it does. But Queen Wayland and KSM server, they are doing other things. They are not asking for more targets or anything, but they are the activation environment which will be used by all the applications which are started by systemd after that. They manipulate that. It's important, for instance, for Queen Wayland because, as the name implies, you get a Wayland compositor, and your applications need to know where is the socket to talk to Wayland, right? So it needs to pass that somehow, and it does that through the activation environment. So we set out to get started, make our first snaps, and to have first the session unconfined. should be easy, right, to have it unconfined. It's just distributed as a snap, but we don't confine anything. We don't force anything with app-armor. We declared 2 services in there, 1 application and 1 service in there. So we declared Start Plasma. We declared the XDG Desktop Portal KDE, so the implementation of KDE for the Desktop Portal protocol. And we fire that up. We expect things to work nicely, and then we get a very nice black screen. So we had to investigate that. Turned out that we had a deadlock between Queen Wayland and XDG Desktop Portal KDE, which was very unexpected because there's no other system where that happens. And because there was this deadlock, Queen Wayland is stuck, nothing can proceed. The compositor being stuck, you get nothing on screen, and that's why you get a black screen. But then why the deadlock in the first place? Do you remember the snap environment variable I mentioned just before, the snap confined positions? Do you remember that Start Plasma manipulates the systemd activation environment? And it does it in a very brutal way, which is I take all of my environment and then I push it all into the activation environment, okay? Which means that anything which is started after that gets the same snap, snap underscore, and so on variables. Turns out that when you do this, all applications are based on Qt, and there's a class which is named QGUI application, which controls quite a lot of things from what happens inside of Qt. And there's something very smart that they are doing, which is checking for the snap environment variable, and if it's there, they say, OK, I'm confined, so the user doesn't want me to do my in-process file dialog, say, right? And instead, I will go through the portal. But if you're Queen Wayland, that means that you have a QGUI application. Because of that QGUI application and because of the snap variable which is positioned, you end up loading the plugin to go through the desktop portal. And then you want to talk to the desktop portal who wants to talk to you. So that's the first big loop there where that cannot proceed. But if you look closely, you also realize that at the same time, XDG Desktop Portal KDE has also a QGUI application which loads the same plugin and tries to talk to itself. Yeah, so that could not work. So we changed that, right, obviously. There are several ways to reduce the issue or to avoid it completely. One thing, we control what's in the base snap, right? So we could say, OK, you know that plugin? We just shoot it out, or remove it from the base snap and gone. Now, the thing, it's not completely perfect because QGUI application does some less drastic, but some other adjustments as it goes, right, in its behavior, so it wasn't perfect. Or you can add your own service, systemd service, which tries to be started before everyone else, but just after Start Plasma, right? Clean up the environment before everyone is there, and then you should be fine, right, because you cleaned up the activation environment. It's kind of ugly, right? But that works. It's what we've been using for a long while, waiting for the patch to Start Plasma to actually be accepted, which is obviously the right solution that you want to apply. And this way, we get an unconfined desktop in all its glory, right? We could log in, log out, and so on. That was fine. But we knew that as soon as we would want to start the confinement again, right, that wouldn't work because we need to talk to systemd, right? To say, fire up that target. Or we need to talk to systemd to say, yeah, change the activation environment for me. And obviously, by default, snapd forbids all of this. So when the security is too tight, what do? You take the power drill out and you start poking holes, right? So we submitted, that's basically what we did. We submitted a new systemd user control interface, which is admittedly risky because anyone who gets that can talk to systemd directly and start whatever service is in the system, and that could be unconfined. But yeah, through that step, we managed to actually get an app-armor profile, which allowed us to actually start things. But the fact that there's a risk ingrained into that interface, that means that that particular patch didn't land yet. That actually will be something else which will land at some point. And that's still in discussion due to this. But yeah, so with that little trick we're playing here, we get the confined session, and so we managed to get something which boots. Now, when we did that, we started to get the thing confined. We found some more errors, right? Some more problems showing up with what the services and applications inside of the session were trying to do. So we had to improve some existing interfaces from Snapd, right? Unlike the systemd user control one. So obviously we touched the desktop, uPower observe, system observe, shutdown. One of the reasons behind this, because that can come as a surprise, because well, there's Ubuntu Core Desktop, right? They're already doing this. Why didn't they get into that? Yes, both are desktops, right? But they have their own code, they have their own lives. Yes, GNOME and KDE Plasma, they are using similar interfaces, but sometimes not exactly the same part of the dbus interface or things like that. Also, the Qt code tends to introspect more aggressively on the bus than GTK applications, so that would show up in the warnings. We wanted just to silence those. Once we did that, declared all the debug services we needed as well, we got confined session, and then it was working. Almost. Because the thing is, if you remember, I said we declared Start Plasma as an application, we declared the portal as a service, but that means that all the other processes in the sessions are actually not confined, right? Because those, we're talking to systemd, right, and said, do your magic with that target, but the service files, they're still there. So it still starts everything else unconfined, right? Which you can actually check. There's a tool provided with systemd, which is systemd CGLS, which allows you to look at these kind of things. And you can see in the control groups that, yeah, clearly those processes are not where they should be. And we would have those files bypassing everything. So we wanted to declare all the other services inside of the Snapcraft YAML as well. We could do that. That's what we did. But then you end up in a bit of a conundrum because the targets, they expect certain names for the services, but Snapd generates services under other names, right? So we ended up having to ship aliases, predicting how the names would be, and that's what we used to be able to get there. Once we did that, we could have all the services confined. We found more interfaces to adjust due to this, but there. We got everything confined, each process even having its own specific confinement rules, right? So because we have everything really as services and not, we're not with a desktop where you would have like one script which starts everything and then everything would have the same confinement. Here we can actually pick and choose, say this one sees that part but not this one, right? Even though they're in the same session. Now you got your session, you want to launch apps, right? Because if I have my session, and then I can list the applications and I cannot start them, it's kind of pointless. So there's a pending Snapd feature for this. We didn't build it, that was already there because it's been needed for Ubuntu Core Desktop itself. And with that feature, you get Snapd to generate desktop files for the declared applications. And then it goes through a snap routine and it talks to a privileged dbus interface for that. And you're only allowed if you use the desktop launch plug, which obviously we declared for use. Now, there's a fun fact about that one. It's that if, like we were doing before, you push the snap variable to the activation environment, then everything breaks loose. And you basically, the applications don't start. You get into a kind of infinite loop. And if you try to boot the session as something is plugged on your session, then you get a black screen again. You have to love black screens. Now for the apps, we're providing building blocks for them. So we're providing several content snaps. We have an SDK snap for just Qt, SDK snap for the KDE frameworks, which are used by the applications. From those two, we derive a runtime snap, which has both Qt and the KDE frameworks, and that's the one which our applications are using. So the applications are built on the SDKs, but then at runtime, they use the runtime bot. And again, those are built from source. Now, for the purpose of the project, we're covering only a few set of applications, and then we have the community picking up and packaging more applications. But we are focusing on a few, which are GwenView, which is an image viewer, Ocular, which is document viewer, CaveWrite, which is just simple editor, Eliza playing music, and Discover to be able to install applications, right? The reasons why we pick those 5 is that through them, you're covering a good set of the overall features the other applications might need. And then we can validate that a user can view documents, can edit them, can listen to music, and it's actually playing, these kind of things, and also can install further applications. So that's good blueprints. With just those 5, we're providing to the rest of the community good blueprints for more application packaging. The good news is, most of them we didn't have much to do, right? With the extension, which the Snapcraft extension that I mentioned before, we got everything pre-wired fairly easily, and most of them didn't require their code to be changed. The only exception to that was Discover, the one which needs to install all their applications, because obviously it has more proximity with Snapd, and due to that, you need to have a bit better integration. So we did a few patches to Discover itself. It was not handling properly, for instance, when you disabled the auto updates for a particular snap. It would be oblivious to that. And there was also a problem with the way it was running a snap which has been installed, because you can install something and say, yeah, please run it for me now. And that was hard-coded to go through snap run, which is exactly the thing you're not allowed to do from within your confinement. That was working because nobody tested it confined this way, right? Everyone tested it outside from the host session. For the applications, we're going one step further, that we are wanting to validate them through GUI tests. That's still under construction because there's a lot of work to do around this. But the goal is that when an application, what we want to get to is when an application changes on the KDE repositories, then it will kickstart building the snap, and then the snap is actually validated by GUI tests, right? So we already have GUI tests for some applications, but if we go all that way, that means that it runs twice. One without confinement and one with the confinement, which allows us, for instance, to test, I'm not going through the desktop portal, and now I'm going through the desktop portal, right? That's 2 very different situations. For that, we're using the Appium setup, which is used in KDE, which is ramping up as I speak. And there's just a few guinea pig when we started. So we've been writing tests for the applications that we package. It goes through AT-SPI, so the accessibility layer for that. And so we found actually issues with the AT-SPI implementation in some bits. So that's actually good, because by doing this, we actually improve the accessibility of what's produced by the KDE community. And we also found issues in the test driver itself, so that helps to fix the test infrastructure for the community. Of course, those tests, as I mentioned, we want to run them on the continuous integration and to go toward continuous deployment for the snaps. And so that's basically what we built. We didn't quite expect to have to build the CI from scratch, because we thought that the KDE community already had some things. Turned out that they pulled the plug out of that one 2 weeks before we started. That was kind of a bummer. But they had very good reasons for that needed to be redone, so we swallowed that one and we were like, okay, we're going to do it. And so what we're providing is we're building, so we're making the YAML files for the applications, the base snap, the session snap, and so on. And the CI then build the snaps from that. In the case of the application snaps, so that's, as I mentioned, work in progress, but we're getting to a point where we want the application snaps to go through the GUI test, and only if they validate those, then they get into the snap store. For the other ones, they are going in the snap store. And right now, so that's one of the other adjustments we want to do. They all go to latest edge. We are right now working into, depending on which branch it's coming from, that goes to edge or to beta or candidate, and then you can validate to Sable later. You also have So that's one part. The other part is building the models, right? To have a whole system and to have an image that you can actually boot. So for that, we have model assertions, which gets signed with KDE sysadmin keys. And those signed model assertions, we get them through Ubuntu image that produces a system image. And with that system image, we slap an installer on top, make an ISO, and those are pushed to the KDE CDN. Now, the thing is, you will notice that on that graph, and hopefully you can see the color properly, some of those arrows are red. That's the steps, and you see that's quite a few of the steps, like almost all of the steps. That's the steps where it doesn't actually play very, very well with the KDE CI infrastructure, because the KDE CI infrastructure is all based on rootless containers. And all those red arrows here, that's the steps which don't play well with rootless containers because you need the root in some way for some of the operations. And that's particularly the case for Ubuntu image, for instance. That's the case also for building the ISO, where you need to do mount loops or things like that. Well, you need to have the root at some point. So the KDE sysadmins have been very nice with us for that. They are actually providing a VM because they have that we can configure to deal with all those steps. They have a plan from moving from rootless containers to ephemeral VMs. And so what we are doing is actually kind of a blueprint of what's to come for the KDE CI. So again, that benefits the community. Now, for the challenges, where, as I mentioned, we had some problems that we encountered, right? So along the ways, we had apps with glitches, and then we had various black screens for different reasons, right? Or the apps not starting. And so the question is, how do we assemble those? How do we tackle those, right? There's basically two cases, in my opinion. You have a problem with your Snap application. You check it also outside of Ubuntu Core, okay? If you have the problem as well, that's a strong indication that the problem is with the application. And in that case, you have plenty of options available, okay? There's Snappy Debug that many people use. We process the logs, see the AppArmor violations, propose you fixes. Nice. You can, if that's not enough, you can use snap run shell, and then you can introspect the environment as seen by the process right from a shell. If that's still not enough, you can snap run strace, and then you can monitor all the system calls done by the applications and their failures. Or if nothing is enough for you, then you can turn to snap run GDB server, and then you basically attach to the process with GDB, and you really need to have debug info here to help. But yeah, you can introspect pretty much everything. That's the easy case in a way, right? Because if that's an application having a problem only in the session that we're providing for Ubuntu Core, for instance, or if that's with the session itself, like some of the problems I described, then what are your options? Well, you can turn to Snappy Debug. It still works somewhat. I mean, it will process the violations properly and so on, but then you should not trust the fixes it proposes, right? Because the fixes it proposes are all written from the perspective of an application packager. But now you're on the other side of the interface, right? So very often it will actually give you the advice in reverse or completely wrong advices. So still useful, but yeah, just be careful that you're not packaging application at that point. And apart from that, you're pretty much it, right? Because the snap run tricks I mentioned before, when you have plenty of processes in interaction, that's not going to cut it. So you need to go straight to lower levels. And then you can, things we've been doing have been to modify the Plasma desktop session startup scripts so that we change the environment before everything starts. And that allows us to enable all the logging we want in Qt, KDE frameworks everywhere, some extra debug logging, and also to tell the user session systemd, OK, put yourself in debug mode and tell me everything you're doing. Then you get all the logs you can ever dream for, because you get actually megs of logs per second. But you get a very clear picture of what's going on. If that's not enough, one thing we did is actually modifying the base snap itself. We have been providing in the repository a small script that we call enable developer access, which does a few shady things that you clearly don't want in production, but which help. For instance, it opened the root access without passwords straight from the first serial port. So you fire up your VM with the image, get to the serial port, and then you can introspect everything you want. It also installs some extra developer tools for AppArmor, PushGDB, and some tools dbus related. And from there, you can basically log in and attach, debug anything. As you deal with problems, you have to really remember, yeah, it's all immutable, right? That's the whole point when you're making your image. It is immutable. That means you have to be strategic in what you prioritize to try when you're trying to debug a problem, right? And you want to validate your theory. Because the feedback loop is not the same depending on what you're looking at. If you need to change an application snap, yeah, the feedback loop is kind of quick, right? You just roll the new snap, install that into your running VM, and then you can see the effect. The Plasma desktop session snap, that's still fine because at the end of the day, it's kind of an application snap, right? You just have to log out first, then you change it, log in, and then you see your impact directly. Snapd is surprisingly nice in that regard as well. Very often, you can actually just upgrade it, right, and try a patch, see how it impacts. There are a few cases where you have to reboot the VM, but that's it. Now, if you need to try something inside of the base snap, then you're in for a long time, right? Because just building it takes a while, and then you need to redo the image, and then you need to boot that, and the first boot takes a bit of time. So the feedback loop on this one is fairly long. All right, so further work coming. So as you've seen from the slide, that was all Core 22. We have the switch to Core 24, which is in the works. We've been waiting for KDE Neon to have a Noble Numbat snapshot because that actually helps us, right? It's not a big architectural impact at the end of the day. I mean, that doesn't invalidate the architecture. We're just changing the base. But that means that even though the architecture doesn't change, you have plenty of components changing at the same time. And then if something breaks, you have to figure out which one it's coming from. So lots of things could go wrong still. It should bring benefits. For instance, the first user provisioning is actually different on Core 24, and we expect benefits from that. Now, the other thing which is coming is a change in architecture. That architecture we used so far is actually, that's a good start, right? That helps to see all the problems we had with the confinement. We confined progressively and so on. But that's not perfect because you cannot easily compose between having a GNOME desktop and a KDE desktop, for instance, these kind of things. So we need to slice things up a bit better. And so we are in the work of decoupling everything from the base snap. So the idea is that we will build on top of the Core 24 base snap. That's what you would get in your image. And in that sense, that would be a standard one. But then it will come with the desktop session snap, which is, again, an application snap. But instead of finding its binaries inside of the base, it will find them in a content snap instead. Right? That's basically the thing we're trying to do, and this way we will decouple. And that content snap, we are figuring, because that will change the prefix in which you find the binaries, we cannot really reuse the dead packages directly anymore, so we will have to switch to actually building everything. Which means that we'll then build on top of the runtime that we already made for the application. So that work is definitely not lost for the session. Lessons learned during that thing, and I will leave you with that, is packaging KDE applications for Snap, it's actually easy. I will be honest there. As I mentioned earlier, right, I've been around free software and so on for a very long time. One thing I really hate is packaging. I really don't like it. But definitely for snaps, it's a very different story. It's definitely easier. The documentation is good. The Snapcraft extension that we have definitely helps. So that's actually good things. The Ubuntu Core Desktop architecture, as you see, we are trying to stick with it, and we are changing along as the upstream, in that case, is changing. So obviously, it has sharp edges, but for now, right, it's getting better, it's maturing. But as it matures, obviously, the documentation needs to catch up, and the tools might have some sharper edges, but that's, in my opinion, temporary. The fact that we confined progressively, that actually made things easier. I cannot imagine the world of pain we would have had if we didn't have that power drill, which I mentioned, which allowed us to start just tiny bits, unconfined, and then confine as we go. If we had to go from everything is unconfined to everything is confined, that would have been much harder. So I'm actually happy we did that. And one thing I didn't mention a lot before, but the Snap Store controls kind of everything. And I was talking about the fact that we have an interface which is not in upstream Snapd. So for a long while, we couldn't publish. So now we can actually do that, but there's been quite some time before we could publish the desktop session snap to be able to use it, which makes the experience for people who want to contribute or for developers a bit harder. And one of the things which I was very pleased with was how we have good tooling to debug systemd-related issues nowadays, which was not necessarily the case years before. If you want to contribute, everything is in public on the KDE infrastructure. So we have the Ubuntu Core project where we have all the scripts and so on to build the images. And then we have a snap packaging group where the base snap, the session snap, and so on are developed. We're also producing documentation to help with that. So there's a how-to for snapping applications. And there's some architectural guidelines and advices on how to contribute to the whole thing integrated on the Neon/Core page there. I will be around. You can come and talk to me, obviously, if you're interested in what we are doing with that particular project. I'm taking credit of everything, kind of, because I'm the one talking here. But obviously, it's an effort of several people. So there's my team at Enyoka Haute Couture, which has been instrumental in doing this. We've been also working with a couple of contractors. So Scarlett Moore, which some of you might know because she's been doing quite a lot of things around Kubuntu around the years, and she's a very enthusiastic snap packager. Carlos Dimain, who is another contributor, more on the KDE Neon side. Fun fact, I have one in the US, the other one in Australia, so for the calls, it's grand. Well, actually, it's easy for me. I'm sitting in the middle. That just sucks for them, so yeah. And of course, we got a few KDE contributors who provided help on their spare time, though, for some of the blockers, mulling ideas over and so on. And especially Ben Cooksley, who is like the person responsible for the KDE sysadmin team. And I'm really glad that he's not hating me yet with everything we've been very annoying on the CI side. So. Thank you for your attention, and if you have any questions, feel free to shoot them.
May?
Please.
This was really interesting coming from my perspective as a Snapd developer to see how people consume all the things we're building. My question is, do you know or have you tried using SnapTry for making fast-paced iterative changes on an environment where you already have everything set up, but you just need to make this one change in this otherwise immutable snap? With SnapTry, it's actually quite easier.
Okay. No, because I was not really aware of it. So okay.
All right.
If we can hook up after and you show me, I would be interested.
Okay, thanks.
So there was some slides you added about contribution by the community, and there was also previously in initial slides you mentioned about launching apps in a confined scenario.
Yep.
So what's the thing currently used, or the API that's used to launch the snaps in this scenario? Can you just
Right, so that's something you get if you have the desktop launch plug and it's actually connected.
Yes.
But that desktop launch plug, as I mentioned, that's a Snapd feature which is coming, which is not in Snapd proper right now.
Exactly. That's not coming. That is there. It's been long because
it's been landed since I wrote that and now.
No. So there is an upcoming feature that it allows us to pass parameters when we are launching the apps, but we can launch the app using the desktop launch plug already. And exactly that's where my second question is regarding community. there was almost, because basically this was my GSOC project this year to fix the snap backend of Discover. But for some reason, like initially there was, I don't remember his name, but there was some guy who came up fixing the launching of apps in Discover, launching the snaps in Discover, and he came up with something like snap routine thing. And then I saw it and I thought, no, it's not the perfect way to do it, rather using desktop launch, and I created a PMR with using the io.privileged launcher debus. But for some reason, it was not merged, and that guy's one got merged, and mine was closed. Like mine is stale right now, but like, and that I haven't seen him anymore contributing in Discover. And like later on was like most of the snap backend issues that were in Discover now are fixed by me. But maybe you can look after that, like the community thing. That I think this is like there are more closed door things, and I think you can be more open with the community about it, because like I have worked on a lot of things, like also the snap KCM that I created. That can be helpful for the use of snaps for managing the permissions. But I think that thing can be improved regarding the community contribution in the snaps.
So for that particular one, so the thing is you have two approaches, right? You can either couple to the debus interface, or you can go through the snap routine. Turns out that there has been one which has been chosen. We are doing it in public, right? It's not like we've been hiding that. So yeah,
not
but
really
then,
hiding, but rather.
No, but then at the end of the day, that the maintainer of Discover a decision, right?
No, it's not. It's not like that. It's
okay,
like the.
Sure.
I talked with him. Like he told me that it was some kind of like, I don't want to say that word, but some kind of pressure.
I think we're running out of time.
Yeah, it's
maybe
fine.
we can continue this after. I guess, Kevin, you're going to be around as well.
Sure.
That sounds great. And also, thank you. It's been interesting to hear the journey, I would say. And let's give a round of applause to Kevin as well.
Can you do that?